This video is a demonstration of how I have approached spatial audio in my project so far, including ambisonic to binaural downmixing and occlusion and diffraction models. I started off by researching binaural renderers that were supported by Wwise and discovered Google Resonance Audio, which is a free SDK package for both Unity and Wwise that can render binaural outputs from ambisonic pipelines. The software utilizes datasets recorded and developed by the Sadie project at the University of York, and is also the foundation of their other platforms such as YouTube VR and Google Cardboard. The package is supported in Wwise 2017 and above, however I'm using the latest version of Wwise, which is currently 2019.2, as this includes new spatial audio tools that are native to Wwise itself. Wwise has recently announced a new 2021 version though that will be released soon, and this will include more spatial audio features including control over output audio devices. In order to test the quality of the Resonance Audio renderer, I created a test project in Wwise and Unity. I started by placing a sphere in Unity, which acted as an emitter for an event in Wwise. I then created a simple script to control the 3D vector motion of the sphere automatically. Then in Wwise I created a very simple pulse train loop and directed its actor mixer sends to the ambisonics auxiliary bus. The bus is downmixed to a binaural signal using the Resonance Audio Plugin. I then went back to the sphere controller script to add dynamic float values for the width, height, and speed of rotation. By creating UI sliders, I was able to control these variables in gameplay without having to access the script. Although the binaural bus works well, it's only effective for the directional location of sound, and a large part of spatial audio is the modelling of acoustic environments. To cover this area of processing, I started by creating a new audio bus to contain individual aux sends to model each acoustic environment. These aux sends are allocated dynamically by the game engine and contain position information. Back in Unity, I created a large cube attached to the AK room script and assigned that to the test room auxiliary bus. I then attached the spatial audio listener to the player camera, which enabled me to view the spatial audio properties within the Wwise game object profiler. On the aux bus, I then adjusted the Wwise reverb room settings to model the desired acoustic environment. To control the reverb level, I created a reverb volume RTPC and connected it to another UI slider. To do this, I created a basic script so that the slider could communicate with Wwise. Now that the AK room is working, all sounds emitted from the inside of the room are occluded from the outside. However, I wanted to create an entrance to the room that provided some diffraction to the outside environment. I did this by using an AK portal script attached to an entrance cube, connecting the room to the outside acoustic environment. In the game object profiler, the green line is the ray trace of the pulse train sound to the listener. You can see that when the sound reaches the portal, it's diffracted towards the listener.